Hello everyone. In this discussion, we are going to present our work on running and deploying a machine learning model across different cloud platforms. We were able to achieve this under the guidance of our professor, Dr. Animesh Chaturvedi sir. These are going to be our table of contents where basically we will be exploring different cloud platforms, their qualitative analysis and quantitative analysis. And we will also be demonstrating a live demo of running the ML model on AWS Comprehend and EC2 and also Google Cloud Platform. In the rapidly evolving landscape of machine learning and cloud computing, the selection of the appropriate platform for deploying ML models is pivotal for success. Our model delves into this intersection, exploring the capabilities of various cloud platforms in facilitating the execution of ML algorithms, with a focus on platforms including Google Colab, Google Cloud Platform, Amazon Web Services offerings such as SageMaker, EC2, and Comprehend. Our endeavor is to provide a comprehensive analysis of their features, performance, and suitability of ML tasks. Although you can run ML model on your local CPU environment as well, but in some cases due to lack of CPU and GPU resources, it takes hours or even days to run large and complex ML models, which is not reliable. So by leveraging the power and scalability of cloud computing, organizations and researchers can overcome traditional constraints associated with the computational resources, enabling them to tackle complex ML problems efficiently. After introducing the project's focus on ML running and deployment across different cloud platforms, let's dive into the process of running an ML model on the first cloud platform in our project, Google Cloud Platform. It offers a comprehensive suite of cloud services including infrastructure, data analytics, machine learning, and more designed to empower organizations with scalable and flexible solutions. We already have created a project on Google Cloud Shell Editor in which we are doing sentiment analysis on movies reviews dataset. Dataset.csv file contains the reviews of around 3000 movies. Model.py file is the training script of our model. After running the training script, we get some of the outputs such as confusion matrix, followed by precision, recall, accuracy, and F1 score with a total runtime of 7.5 seconds. Results get saved in output.csv file after running the training script. This is the output.csv file. We are also hosting our model using Flask framework that is in app.py file. After running this file, Google Cloud provides a hosted link where our model is deployed with some styling using HTML and CSS. This is our website. Let's provide some input to it. For example, I am neutral towards your opinion. So our model predicts the sentiment as neutral. This is the best movie I have ever seen. Our model predicts this as positive because it's a positive review. And then this is the worst movie. Since this review is a negative, so our model also predicts this as negative.
So now let's move on with the Amazon Web Services. The Amazon Web Services consist of the two services that we have used. Firstly, the Amazon Comprehend, which consists of the sentiment detection job and the real-time analysis endpointing with the testing inference, and the Amazon EC2 with the end-to-end model deployment. So Amazon Web Services is a global leader, as you can see, and it is a pay-as-you-go pricing model with the seamless model deployment and can be used for custom model sentiment detection and other ML services. This Amazon Comprehend is used for the sentiment analysis and language detection, as we will see a real-time live demo for the same thing. Now let's move on with the live demo. So here what we do is, firstly in the bucket we upload the data in the form of CSV file. Here you will see the final temp dataset.csv. So we will create and we will upload the dataset. So after uploading the dataset, now we will move on with the Amazon Comprehend here. To use the Amazon Comprehend, we will go on with the custom classification job. This is the job for the real-time endpoint testing inference, and give the name as sentiment detection job data classification, and use the single label mode, and provide the custom input directories and the output directories with the IAM role suffix name. And then finally create the job. After creating the job, as you can see, the job has been created. So now we will click on that specific job which is trained. And as we can see here, this is the input and the output location, and this is the performance metrics with the precision of 91% and accuracy of 90%. Finally, we will move on with the endpoint and give the name as final endpoint and choose the sentiment dataset classification and put the inference units as 1, and then finally create that endpoint. In the real-time analysis here, as we can see that if we type the sentence, this is the best movie that I have ever seen, the predicted output as the sentiment comes positive. And if we type a sentence like this, which is of a negative type, then the sentiment comes as negative. So now let's move on with the second job, that is the sentiment detection job. These are all the steps that is used in the sentiment detection job, and we get the performance metrics and the .csv file as the output. Now let's move on with the live demo of it. As we can see here, in the real-time analysis jobs, we are completed with the real-time analysis. So now we will create a new analysis job, which will be named as final IMDb sentiment job. And it is very important to choose the analysis type as sentiment, because we are doing the sentiment analysis classification job. So we choose here sentiment and the language as English, of course. Give the appropriate input data location. Here our input data location is in the sentiment cloud bucket, which is the final temp dataset.csv, and also the output location for the output to be stored, which will be the sentiment cloud bucket itself, the sentiment cloud bucket. Yeah. And also we will give all the IAM role permissions and create the new role itself, which will be named as sentiment detection role, and then job creation will happen. And in the output data location, after the training is a file which will be downloaded. So after downloading it, in the file ahead we will be going to see that it contains the 4 labels, that is the mixed, neutral, positive and negative. So let's see that accordingly once we open it with the notepad. So for the first sentiment review here, as we can see that the sentiment that the output it is giving is negative, because it has the highest score here.
A scalable computing capacity in the cloud. It gives us a resizable virtual environment machine or instance for our on-demand launching and termination, with which we can deploy our server. Integrating WinSAP software enables the file transfer between our local and server file system. So these are the steps which we'll be following throughout this deployment. First, we will train our model and save it as a .pkl file. Then we will launch an EC2 instance. Then we will create an Ubuntu version 22.04, which is the latest version, and transfer all the files on it. Then we will run our app.py file, and all this code is in this GitHub repository mentioned here. Now let us look into the deployment. First, we will search for EC2 in our Amazon console home. Once we click on EC2, we will launch a new instance, and which we will deploy our server. We will give it a name as new_deploy. Then after giving it a name, we will select an latest Ubuntu server here, which is a free tier available server with version 22.04. We need a new key pair with which we can log into our server, which is an RSA encrypted key with .pem format, which will be downloaded once we create this key pair. After that, in the security group, we have to allow all the traffic to our server, that is HTTPS and HTTP traffic. After this, we will launch our instance. Once our instance is launched, it will show us as a pending status. After the status is in running state, we will get our public IPv4 DNS, which will work as our host name in the WinSCP app. So we will paste it in our host name. After and username will be Ubuntu, as we have created an Ubuntu server. For the password, we will use the downloaded key pair, which is new key pair.pem file. After clicking the login, it will authenticate with our server, and it will create a connection between our local file system and the server file system. After that, we will upload all the code, and we will install all the requirements which are required for our server. So in the same software, we can launch our terminal, with which we can run our file, that is app.py, which contains the Flask server and our model. So after running Python 3 app.py, we can see here our server is running on the local host in the cloud computer. And if we go to our Amazon instance, we can use our private IPv4 DNS as our website link. So we will copy it and we will paste it in the new tab with our port, that is 8080. Here we can see our website is live. So we can give any reviews. For example, if we give this is the best movie and hit predict, we will see it is giving us positive. And if we give this is the worst movie, it will give us negative.
Now we will dwell into the deployment of a sentiment analysis model on Google Colab GPU platform. It provides easy access to GPUs and TPUs, making it well suited for various tasks. Upon accessing the platform, we seamlessly established our ML workspace by logging with your Google account and initiating new Python notebook. Within this environment, we leverage pre-install libraries such as TensorFlow and PyTorch. Further, we install additional libraries via pip command directly within the notebook. After that pre-processing and model training, we evaluated our model's performance with various metrics such as accuracy, precision, and recall. In this slide, let's have a look at integration of Colab GPU with WANB. So WANB, which stands for the Weights and Biases, is a powerful AI developer platform that streamlines your machine learning workflow from end to end. It can be used for efficient training, real-time metrics tracking, etc. The image shows the confusion matrix, which is a tabular representation that compares the actual and predicted classifications made by our model. The confusion matrix depicts all the true positive, true negative, false positive, and false negative values for the sentiment classification of our model. We have calculated various metrics, which I'll be discussing ahead in our presentation. The image demonstrates the various graphical representations which show the various performance metrics. They play a pivotal role in real-time monitoring and decision making. I will explain a few of them. First is network traffic in bytes. This graph illustrates the amount of network traffic received and sent over time. Second is disk input-output utilization. The y-axis represents disk input-output utilization in megabytes. Additional graphs include disk utilization in GB, utilization in percentage, process CPU threads in use, and process memory availability. Now in this slide, let's have a look at the quantitative analysis table. We have evaluated the comparison study for cloud platforms such as AWS Comprehend, local CPU, and Colab GPU for sentiment analysis. We examined memory utilization and performance metrics, including accuracy, precision, recall, and F1 score. AWS Comprehend demonstrated cost effectiveness but introduced latency. Local CPU solutions were budget friendly, and Colab GPU efficiently utilized memory and provide faster interference. Now Karthik will continue with his final conclusion.
So finally, we can say that in the AWS, it is better for using the large datasets and the sentiment analysis model, as it also provides a scalable storage as well as the EC2 platform for the deployment. And the GCP, the Google Cloud Platform model, it can provide the Vertex AI services as well as the shell. And the Google Colab can provide us the GPUs as well as the real-time collaboration. This project was done under Dr. Animesh Chaturvedi's guidance. Thank you very much.